Hello, everybody. We are starting now. So, this is me, and we will be talking about easy to test and modern Kubernetes applications using Knative today. I'm Chris. I working on Knative at Red Hat. So, couple of information here about me, but let's go ahead with the agenda today. So we'll be talking about first about a bit of history, then I'll try to define what the apps of the modern era could be, and what are serverlesses, and also what is event mesh. And at the end, I will show how we could achieve all of that using Knative. And maybe in the end, we could do quick question and answers session. So starting with history, essentially, I have here some history of computing, and we started having all hardware only, and gradually we started to going more and more away from the hardware by doing programmable ROMs and punch cards. Then we invented the Unix system, the C language, modern languages, and Linux are followed then. And after that, we have things like virtualization, containers, clouds, and now we are essentially about here at the hybrid era and doing cloud native applications. So one thing to remember that we gradually move over from hardware to essentially add another layers of abstraction on top of that. But our solutions are still way back in the past. Sometimes, for example, databases are started around the same date when the punch cards and programmable ROMs started because of the hardware limitations that we have back then. Yeah, so the design of our apps are often still in the past. So examples, couple of examples. For example, we have this prevalent application architecture that we have a server, we have a database, and we have a client, and we are doing transactional processing on everything. So a request is coming, and we are doing transactional operation. If anything is wrong, we are rollbacking that operation, and this is essentially wrong idea because the real world doesn't work like that. If, for example, we do we order something from anybody, that only transactional operation is that order. Anything except that could be processed in the future asynchronously without the transactional processing. I mean, it should eventually be consistent with this order. So the payment should be processed, and we should send an email, we should send the product, and so on and so on. But it's not the same transaction. And often we have this design that we are trying to break our applications from monolith to sub microservices, for example. And our microservices are starting to create a service mesh. And then some of those applications have their own data stores, and we have multiple entries to that system. And on top of that, we start to divide those to separate teams with separate pipelines, CI/CD pipelines, and this is becoming way too complicated, way too complex to handle and to understand for most of the people. So to tackle that, we need new ideas. Essentially, we need new things, new ideas to tackle those problems, right? Yeah. So what could we have? For example, we could write our application to be 12-factor app capable. We could have microservices. We could separate the command from queries. We could do event sourcing. We could write application with like clean architecture, ports and adapters, for example, hexagonal, that's another name. We could start leveraging the eventual consistency pattern, right? And ease of testing is crucial, right? And the question is which to choose, because you go to conferences and often people are talking about one specific idea, but those are really just tools, and we need to pick essentially all of them, but we need to know when to use which one and how, right? And that's how real professionals are doing the job, because the tools, like for example, you have a carpenter and we have a hammer and we have a saw, for example, and asking, should I use only the saw or should I use only the hammer? It's not a valid question, right? We should be using the tools that are appropriate for the task. And also, on top of that, we need to do things that are essentially required to do in order to adopt any new ideas. We have some things like on-demand, elastic infrastructure, automation. We have CI/CD and deployments, pipelines, advanced deployment techniques, and only after that we could think about doing microservices, right? Because without those, it's really hard to think about doing any of this. So serverless computing, what it is and how serverless computing will help. So serverless computing essentially is a concept that we build and run application without requiring any server management. So if we think about that graph, timeline graph I showed before, we are moving even further from the hardware now. So we don't really would like to think about server management. And that's essentially the serverless computing. And the serverless pattern works like that. We have some kind of event, like HTTP call, Kafka message, or any other event, and that is inducing our application. The application is producing something, the output, and essentially this is it, right? But the serverless pattern is different from other situations because our application is only there when we need it. So if the application is not needed for processing, it is not there. And also it is scaling automatically to for the demand we have. And it is similar in case of Kafka or HTTP. This is really the same concept. So the serverless has operational gains because we don't have static resources. Our resources adoption will try to follow the request pattern. So we will not be overspending and underspending. So both of those situations are problematic. So serverless will give us that. And there is also an event mesh. Event mesh is a concept that is not often talked about. And what it is, the event mesh, and how this can help us. Essentially, event mesh is a configurable and dynamic, again, layer, abstraction layer, that is used to distribute events to applications. So in other words, we have something that is called this event mesh, and we use that to send and route our events to our applications, right? So we don't configure where we would like to push the event, but we can inside of the application, but outside, right? So it's dynamic, so it can be changeable during runtime, and we could be configurable during runtime. So it is application. If we use event mesh, application doesn't really know what is happening with events after they have been fired, right? Yeah, and this is some kind of comparison between service mesh concept and event mesh concept. I've put it here because people often are aware with service mesh, but they don't really know about event mesh. So this could be helpful for you. So there are similarities like the flexibility or robustness or decoupling. This is the same for both patterns, but there are different key differences. Like the service mesh is for synchronous requests and responses. So we have something that is blocking, and we are calling some service, and we would like to have the response from that service. So this is the concept of the service mesh, and then we would have a retries and all the things that service meshes could do for us. But event mesh, on the other hand, is asynchronous, and it is based on events. So the events doesn't have response. We just fire the event, and the event is going to the event mesh, and we don't, from the point of view of the application that fires the event, after the event is accepted, the operation is already done, right? So service is better for queries, and event mesh is better for commands. So if we go back to that idea of command and queries responsibility pattern, we should maybe choose to have event mesh to process the commands. And for queries, we could use service mesh if we need, because queries are often simple and we don't really need a lot of services to build a query, right? Because we could ask a data store to give us an answer, and we have an answer directly. So queries often, if we do this in this way, we often don't need to have a service mesh, just the event mesh and queries directly going to data store. So if we go back to that slide that I was showing back then, and now I just replaced the lines here from service to service, from being synchronous to being asynchronous. And now they are representing events. So if you imagine, we just coming from outside, we are doing something and we are firing event, and then our request could go back to the client. And so the processing is really quick, and the event then is processed on the background afterwards asynchronously, and in the end the whole system will reconcile into the consistent state, and that's it, right? So application is quicker, responsive, and is doing only things that it's supposed to do. Yeah, so now I would like to show you the actual one of the implementations that could be done with this. So this is something that I'm working on. It is Openshift Serverless. It is based on Knative project. And the Knative is a Kubernetes extension that allows you to deploy and manage serverless apps. And Knative in Openshift is basically, Knative is a CNCF open source project. It is community driven with multiple stakeholders like Google, Red Hat, IBM, VMware, Mesh, SAP, and more. Here are some resources for this. The latest release as of now is 1.25. It is based on Knative 1.4. So we already GA, we already have customers, so it's production ready system to use as currently. And Knative has those two components, serving and eventing. And basically, serving is doing a request-based model that you could scale to 0 and scale to demand, to your demand. And eventing is essentially event mesh implementation. Yeah, and now I'd like to show you the demo, the first one. So here we have a cluster. Maybe let me show you this. This is the cluster I have. This is Openshift, and it's already have installed the serverless operator on top. So we have serving and eventing installed, and we will deploy a service using our KN. So I'm creating a service called Showcase with this image that I have here. And when I do that, the service is being deployed, and I have here a request. So I could HTTP it like that, for example. Here. Yeah, and I have a response, right? So the application is working. We could also see it on the interface here. So we have a running pod, and the application will serve our request for us. So this is the application, and after some time, a minute exactly, after default settings, the application will automatically scale down. So here you can see there is running one pod is running. So after about 60 seconds, the serving will automatically scale it down to 0. So it will no longer be taking our resources. Yeah, so it will happen in a couple of seconds, I think, because I've done a request recently, so we need to wait that time to see it happening. Okay, so let's go maybe to talk about the serving for a while after we go back to this spot and see if it's scaled down. So it's serving is easy routing and scaling to 0 and to demand with automatic revision tracking, right? I could show you this. Oh, here we have this event that we have terminating. So our service is already scaling down, and it will scale to 0 already. And we have, if we go here, yeah, we have 0 pods running right now. So the deployment is scaled to 0. And we have one revision, because this is just the first revision of that service that I deploy. So we have revisions. So every change on that service, every change of environment variables or image will create additional revision. And we can also use traffic distribution to route between those revisions. And that will be something next. Yeah, but serving concept, we have the automatic request-based scaling, including scaling to 0 that I showed 1 second ago. We have separation of code to the configuration. This is the opinionated deployment model for serverless applications, and we have this traffic routing capabilities for deployment of new versions. So we could deploy ahead of time and only then scale to appropriate values. So this is the resources that service is using. I mean, we have the service, but this service is Knative service, and it managed the configuration, revisions, and routing. So you could see here that, for example, we could route 10% to some revision, and the other 90% 90% to the other revision, and so on. Yeah. So this is also something interesting, because the one fun thing of the Knative service is that it actually simplify a lot the deployment of Knative. We no longer need to write a wall of YAML text to just deploy the service, the routing, the autoscaler, and then maybe we would like to also have a ingress deployed to have this service public. All of that is done automatically with service, with just those couple of lines that are written in black. So the other lines are not really necessary, and it is doing all of that for us automatically. Yeah. So we also think about developer experience a lot. So I already showed you the KN. That's our CLI that we use to deploy services and also parts of the eventing to simplify the life of the developers. So I will show you now another demo. What I'd like to show you is essentially I would like to autoscale this service, and in order to do that, I will update that service a little bit. So I'm essentially just adding an environment variable called delay with 2000 milliseconds, and I'm adding a concurrency limit of 1. So this application that I have here is written in that way that when I do a request on the hello path, it will wait for 2 seconds basically. So this allows me to show you the automatic scaling of this application. So I could call, for example, hey to the hello endpoint, and it is doing the auto scaling already. So if we go to the this interface, we see that there are already 15 pods being created. Some of them are running already, and some of them are still starting, and the request will complete in a minute. So one thing that is to keep in mind is that we automatically scaled this application, and is also 100% of those responses completed. So the requests were going to Knative, and they are staying on our queue in time when the application is starting. And if your application is quick enough, that is should be for serverless serving, the responses will just be routed to the all apps that are starting in this time. And as you can see, all of them are those responses are successful. Yeah. So this is the auto scaling in the nutshell, basically. Yeah, and we have also serverless eventing, right? So the serverless eventing is a universal event mesh based on sources, brokers, channels, and sinks, and it's doing all of that using the CNCF cloud events. So the what are those? What is this serverless eventing? It's based on the CNCF cloud events, and those are just regular HTTP events. I mean, regular HTTP REST operations, and these cloud events is just a specification for any language. So we could write and capture those events in any language, even Bash, even any language, Java, Python, .NET, whatever you will imagine. There are also libraries written by cloud events for popular languages, but it's not limiting to you. You could just create those cloud events using the specification for your language, and here we go. And you send those events to event bits, and those are brokers and channels. And you can configure those brokers and channels to route your events to the target you would like to have in your production system. So there are a couple of implementation for those transports. There is a in-memory transport that is only for development purposes, but we also have a Kafka implementation that is there in our product. But there are also other implementation like, for example, Google PubSub. And we have routing based on sources and sinks. So sources are those places that are creating events, and sinks are the places that will actually capture events and process them in some way. Yeah. And what to capture from this is essentially that first part is most important, because if the events are just HTTP requests and responses, it will greatly simplify your applications and make it that they are really easy to test. Couple of sources, we have some built-in sources like ping source, API server source. Those are maybe only for development purposes, but there's an interesting sync binding source that will actually configure your application so that the application will know where to send the events. So I will showcase that in a second. And there are other sources like GitHub source, Kafka source, CamelK source, and using those we could create sources of our events in this decoupled way. Yeah, and there are two ways of delivery. We have a direct delivery from source to sink, so we specify the sink on the source, and that could be anything. It could be Knative service, it could be another eventing bit, or it could be even Kubernetes regular pod or service. So this is the easiest way to send cloud events to the service, but it has some disadvantages, like there is no queue to support if the service is unavailable, and there is no back pressure mechanism that we have in other way of doing things. Yeah, so there is no filtering, of course, and the sync will always get all the events in that way. But this is the better approach to do it. So we have, for example, multiple sources. We have a broker, and broker already has a queue, have a built-in back pressure mechanism, and also it could have a persistence, like for example Kafka has. So we are sure that our events are safe and will not lose them. So, and broker then decide what to do with those events based on some filters. So we could define those filters and say, for example, by the attributes of the cloud events, like a type or any other attribute that the cloud event could have, we could decide, okay, if this type is X, let's go orange, for example, let's go to this sync, and if it's green, let's go to the other sync down there, right? So we are designing that completely outside of our applications, so our apps are not aware of this configuration at all. Yeah, and quickly, the event mesh demo. So we have already the service that will be our source of the events. So we will just deploy a binding for this. So I will create a binding to this service, and I will say that it should be the sync of that. It should go to the broker. Yeah, like that. But I don't have a broker yet. So let's first create a broker and create a default broker. Let's go to the view. As you can see, the broker is already created. It is here, represented by this icon. And now it should be possible to create this binding to this broker. And we have this binding created. This binding, we have this line that shows us that from this source sync binding source, we are getting our events transmitted to this broker. And this sync binding source actually changed our service, because we showed here that the subject should be our source, our service. So that's why we have a third version of this service. And if we go to that service, we could see these details of that service and what has been changed in that service. And if you could see here, previously I added the delay parameter, right, the environment variable, and now we have a ksync environment variable, and the value of that is filled in by sync binding. So the sync binding actually changed our service to have this environment variable. And one thing that our application needs to do is just to understand that it should send events to the ksync environment variable. So the application is obviously configured to do that. And now we need something to do with those events. So we need some kind of sync. So I'll create here another service, or maybe let me deploy a service, a sockeye service. One second. A sockeye service will be, it's a also one kind of development service. It is written by one of the founders of Knative. Let's see. Yeah, we have this sockeye, and the sockeye service is just an application, and that application is showing a list of events in a table here. So we will be having it here, and I will use the UI of the our OpenShift console to just route those events. So I could drag this line here and tell, okay, I would like to send the events from this broker to this service. And here I could specify the filters, but I will not specify them for now. And now, as you can see, we have now a full line from the source. So those two things represent our source effectively. The events are then sent to the broker, and broker decide by the attributes. In this case, we don't say anything about that, to send the events to, and the events should be going to this service. So we could see that there are no events here. Our service, input service, is scaled down to 0. So we go to the service. The service is scaling up, and it is now working. And we could go to the hello service, hello endpoint here, and that will invoke the operation, and the event should be sent. And as you can see, the same event has been delivered to the sync. In our case, that sync was this sockeye service. Yeah, all right. So that's essentially it, and how the Kubernetes native apps could look like. Essentially, the apps using Knative, along with, for example, Tekton, are natural to Kubernetes, because those are essentially extensions to Kubernetes. And we could cover all of our initial ideas with those while avoiding the vendor lock-in at the same time. So that's something really awesome, right? And let's take a look. We have 12-factor apps. So how that's covered? Basically, if you go to the site and take a look, Knative together with Tekton and OpenTelemetry will essentially cover all of those 12-factor apps recommendations that they have there. Next, we have microservices or functions, and those could be covered with Knative serving and maybe Knative functions as well, or maybe your own implementation of functions. Then we have a command query separation. I will advise you to have a serving for queries and eventing for commands. And also that is interesting that even if you have legacy application that starts slowly, you still could use event mesh eventing for commands. So you could process your events with eventing even without using serving, of course. You could use event sourcing, although I don't recommend using that always because it's complex. But you could do that, and you could leverage persistent event mesh based on some event store like Kafka, or maybe event store database, or any other database that could be persisted, and the events could be replayed, and the projections could be recreated. There are some architecture patterns that we should follow, and basically that nobody could save you from that. So you need to just code nicely. And we have eventual consistency here, and eventual consistency here, I will advise you to take a look how the Kubernetes is working, because we have the reconcile loop in the Kubernetes operator. So we are aware that if you create some Kubernetes resources, custom resources, the Kubernetes will then start to reconcile them, and will do that as long as it doesn't reach the consistent state. So example, if your image that you're trying to deploy your container with are not available, you will have your service in a crash loop backoff state, and Kubernetes will try to deploy that service using logarithmic backoff as long as it could. So after you deploy that image, it will actually try once more, and if it succeeded, it will end that processing. So we could also write our business application that way. So after we have an event and we couldn't process this because, for example, we have an exception in our logic, then we could deploy another version of that application, and another version could be fixed already to properly process that event. And after that, the event will be consumed and processed properly, and the state of the system will eventually be consistent. So in a successful situation, that's of course a couple of seconds of processing. In the failure case, we are talking about minutes or maybe hours of the development loop and deployment until our events are processed properly. Yeah, and the end, there is ease of testing, and with the eventing that could be done really easily, because all of that are just HTTP calls. So HTTP calls are really easily to test. We have multiple libraries to do that. Here are some resources to follow about the serving and Knative in general, serverless concept, a couple of resources that are interesting, and that's it. I will now, if you are interested, you can write some messages in the chat. I'll try to answer them. You could also take a mic and ask directly, so I could answer live your questions. So thank you for your attention. Any question, just write on the chat or raise a request for voice in the Hopin platform, and I could invite you on the stage, basically. So we have about 5 minutes to the end. So if there are any questions, go ahead. If not, thank you very much. Once again, let me show you this page for the resources. I'm seeing some people on the people list. I'm not familiar with anyone, actually. Yeah, but if you have any questions, go ahead. I will answer them. Go ahead. Ask a question. Don't be shy, or pick up the mic. Maybe you have a question not related to Knative or serverless, but the other topic like open source, Red Hat, or whatever. Thanks, Pavel. Nice for your message. I'm happy to hear that. All right, so I think nobody asked any questions. So thank you very much for your attention. Let's maybe connect on the networking page. If you have any question there, maybe you could ask me directly. And thank you very much and see you. Bye.